when inserting inside of a BST and coding for it, we're going to code there's two ways. One is recursive, using a recursive function. The other way is iteratively, meaning using a while loop or a for loop. Now, if I show you these two ways, right? First we have a 5. Okay, now this is a node. Then I want to insert a 7. So I'm going to check, right? Is 7 greater than or smaller than 5? It's greater, so it's on the right hand side. We add it at the right. Okay, so step number 1 would be to check which one is greater than, which is like whether you want to insert on the right or on the left. And then after that, you want to check for, let me just go by 2. Okay, so insert 2 is smaller than or greater, it's smaller, so we insert it on the left. Then we insert 8, right? So now we have to go again checking 5, starting at the root. It's greater than 5, so we go to the right, we go to the 7. Then we check for the 7, is it greater than or smaller than the 7? So it's greater than, so we go one more to the right. Now another thing you have to note, which is step number 2, right, is the fact that I'm inserting only when I find null. Basically when I find that there are no children below that node. Look, 8 was greater than 5, but I never inserted on the right. I never made this one 8. Okay, I kept it a 7. So then I went to the 7 and then I checked if the node of the 7, right, if 7 had a node on the right side. It didn't. Then I'm inserting 8 there. But if it did have a node inside there, I'm not going to replace it with an 8. I'm going to check that if that node has no children at the right hand side, then I'm going to insert the 8. So that's another thing you have to check out. Right, you have to find null for insertion. Find null. Okay, now we come to we inserted 8. Now we check 9, and 9 greater than, and greater than, so on the right hand side. So this is how our tree would look like. Fine. So insertion happens like that. In terms when we coding this, okay, things are going to look a bit different. Not that much though. Okay, so we're gonna first of all write void insert, and we're gonna pass a parameter, basically the data that we're inserting. Fine, easy. For now it is. After that, we're gonna have one edge case. We're gonna test if our root node is equal to null, just like we did in a linked list. We always check if our root is null. If it is null, it means our tree is empty. Okay, because remember when we inserted the 5, right, our root node was empty, we didn't have a root. So we assigned root equal to new node and data. And then don't forget to return. However, if root is not equal to null, by the way, there should be a double equal. So if root is not equal to null, then you're gonna make a temporary node, okay, and make it equal to root. Because now we're gonna remember in a linked list we had a temporary node and we made it equal to that. Now this temporary node is going to hop around a couple of times. Okay, it's gonna be there and it's gonna check if this is null. If it is null, then we're going to insert after it. Okay, so that's what this is all about. Okay, we're finding a temporary node, making equal to root, and then we're gonna do something like a while loop. Okay, and this is going to be an infinite loop. We're gonna have, well, not really an infinite, but I mean you're gonna make its condition true so that it keeps iterating. And you're gonna have 3 kind of they're gonna have an if statement inside of there. Then you're going to have, let me just put the brackets there. After that, you're going to have an else if statement, and then you're going to have an else. And just bear with me, don't really ask much questions, just it is like this. Okay, after the else you're going to return. Okay, simple and easy. Now in the first if statement, what you're going to write as the condition, you're going to write step number 1. Okay, step number 1 was right or left. You're going to check whether to go right or left. Now how do we do that? We're going to check if our root node is greater than the data we entering, or is it less than the data we entering. So assume the data I want to insert is 7. So I come to the root, and now I'm gonna, now t is at the root. Okay, our t is here. Alright, t is at the root, because remember we made here t equal to root. Okay, just bear with me. T is at the root. Now you're gonna check if t dot data, alright, data, which is 5 at this moment in time, is that greater than or smaller than 7. Okay, so that's what we're gonna check. Let me write the condition. If t dot data is greater than, and by the way, take note that it can never be equal to. You cannot have a duplicate entry inside of a BST, alright, in a binary search tree. So now we have data. If our data is greater than the d, you know what d is? D is this number that we're inserting. See, I'm inserting 7. So if data, if it is greater than, remember I said if the root node is greater than the data you're entering, right? Basically it means that the data you're trying to enter is smaller than the root node, then all small entries go to the left, right? So then you're going to have to go to the left. Actually no, stop if statement. You're gonna say t is equal to t dot left. Fine, perfect, easy with that. Now just bear with me. Let's come to the second else if statement. We're not done here, by the way, but now this is the thing. Else if our data can be smaller than the data we entering, so you know the data we are entering can be greater than the root node's data, and in that case we want to add to the right hand side. So we're going to say t dot data is greater than d. Okay, meaning the 7 is greater than the 5. Remember, this is our 5, t dot data is 5, and the data we entering is 7, so it's greater than 5. In that case you want to add to the right hand side, isn't it? So yeah, then we want to recover the condition where that's going to happen. So I'm going to say t is equal to t dot right, meaning go to the right hand side. Now here's the thing, we want to stop this also, and there's certain condition when we want to stop it. We want to stop when, that's where step 2 comes in, finding null value. Okay, when we find a null value, basically there's no child at the bottom, that's when you want to add your 7 or your d, basically your d, you want to add it then when you want to find a null. So I'm going to write an if statement here, and I'm going to say if t dot right, actually no, not right, left, because we're going to the left. Remember left, because our data is greater than, our data that we're entering is smaller than the data at the root node, so we're moving to the left hand side. So I'm going to check if the left hand side value is equal to null, and if it is equal to null, then I'm going to do two things. One thing is that I'm going to say that t dot left is equal to new node data. Basically I'm entering the data, or I'm creating a new node here, and once I've created that new node, I'm going to return. Okay, that's it. And the same way you're going to do the exact same thing inside the else if, except that you're going to change the left to right. Easy as pie. So yeah, that's insertion code, quite simple. You just have to know the algorithm and know what you're doing, and then you'll be fine. It's not really difficult, it is quite easy. So thanks for watching.